Alright, I'll finish up the last few problems. So we got 24 equals equal values of 4x minus 3 plus 7. So first we're going to subtract 7 to get the 4x minus 3 by itself. So we get 17 equals whatever, I forgot what these are called, minus 3. So now, if you have the straight parentheses, you can have to set it up two ways. So you got 4x minus 3 equals 17. And we got 4x minus 3 equals negative 17. And I'll show you why on a little graph real quick. So if you have equal values of x, I think that's what's called, equal values, I could be wrong. You're going to have 1 point here that's positive and 1 point here that's negative, but their y value is going to be consistent. So if we're at 17 up here, let's say that's x equals negative 17, right? Or x equals 17 there, and x equals negative 17 over here, gonna have to have one directly across, and that's gonna be your other answer. So that's why you have a positive and negative for this kind of function. So now you can solve it. So we add 3 to the top one. So we have 4x equals 20. X equals 5. And then add 3 to the bottom one. So you got 4x equals negative 14. We got x equals negative 14 over 4, which is equal to negative 7 over 2. And now I gotta plug it back in. So we do 4 times 5 minus 3. So that's going to be 20 minus 3, which is 17. Equal values of that. So that always makes it positive. So it'd be 17, the positive thing of 17 is 17. So 17 plus 7 is equal to 24. That's true. And now I'll do the other one. Negative 14. This one will be easier to multiply by 4. Negative 14 over 4 times 4 minus 3. So you notice 4's cancel here, so it's negative 14 minus 3. And then equal values of that, which is negative 14 minus 3, is negative 17. So the positive version of negative 17 is 17. 17 plus 7 is equal to 24. So I know that's also an answer. So these are our two answers right here. Alright, so this one is it's already all by itself on the left. So we'll just do 4x plus 10 equals 6x, and 4x plus 10 equals negative 6x. So for the top, we'll subtract 4x from the left side. You get 10 equals 2x, x equals 5. And the bottom one, subtract 4x, you get 10 equals negative 10x. So x equals negative 1. Now you test them. 4 times 5 plus 10. Which is 20 plus 10, which is 30. So we're going to have the positive version of 30, which is 30. So 30 equals 30. Oh, 6 times 5. We'll do 30 equals 6 times 5 because it's 6x and x equals 5. So 6 times 5 is 30. So 30 equals 30. Basically just skipped one step. Alright, next one. 4 times negative 1 plus 10 equals 6x. 6 times negative 1. So 4 times negative 1. Sorry, I'm just thinking because it's thinking ahead. So it's going to be 6, negative 6 equals... There we go. Alright, so negative 6 equals 4 times negative 1 is negative 4 plus 10 is going to be 6. Positive value of 6 is 6. 6 equals negative 6. Now this isn't true, so our answer of x equals negative 1 is not true, because 6 does not equal negative 6. And that's why if you do get two answers, just like plug it in. You don't have to write it out, but just plug it in your head and make sure it does equal and it is correct. Otherwise you get probably like a few points taken off. Now I'll do the last problem, find the missing terms of the sequence. So it goes from 0 to 1.5 to p to 4.5. I know it's going up 1.5 here. It's going up 1.5 here. So it must be going up 1.5 here and here. So I'm going to say it's adding 1.5 every term. So we're going to write T of n, because T of n is the thing they use for explicit and recursive, or I mean geometric and arithmetic. This is going to be 0 is our first term. So to get our 0 term, or our y-intercept I like to call it, we're going to subtract 1.5. So 0 minus 1.5 is negative 1.5. So we'll do 1.5 and minus 1.5. So this is basically, if you want it in y equals x, it'd be like y equals 1.5x minus 1.5. Now if we had 0 for x, it'd be 1.5 times 0, which is 0, minus 1.5. It'd be y equals negative 1.5 when x is 0. So that's how I got this number over here. Alright, next one. Oh, sorry. Alright. It's gonna be multiplying every time. So it's getting slightly bigger. Yeah, I don't know off the top of my head what it's multiplying by. I think it's multiplying by 1.2. Could be wrong. Let me check real quick. Yeah, it is. So I'll go back. So it's multiplying by 1.2 here, and it's multiplying by 1.2 here. Because negative 1.2 times 1.2 is negative 1.44. So we're going to write t of n. Now to find our zero term, we're going to do negative 1.2 divided by, this way is multiplication. So to go backwards, to 0, this is our first term. To go to 0, we have to divide. So negative 1.2 divided by 1.2 is negative 1. So it's going to be t of n equals 1 times 1.2 to the nth power. So I'd try this out real quick. We'll say this what we want. We want when n equals 2, which number the nth term in the sequence is 2. So do 1 times, it's going to be negative 1. There. Negative 1 times 1.2 to the second. Alright, so we're trying to find if the second term, or if the equation works for the second term. Alright, 1.2 squared is 1.44. So you get negative 1 times 1.44 equals negative 1.44. And I know right now that they are equal. It's negative 1 times 1.44 is negative 1.44. So I know my equation, this equation right here, is correct. Now for this one, it's getting increasingly smaller every time, so I know it's going to be geometric. So 100 to 90 it's losing 10. And for geometric, the only way that can happen is if it's multiplying by 9 over 10. For arithmetic, it'd be minus 10, but if it was minus 10, it'd be 80 for the x. I don't know why I wrote 10. It'd be 80, and then it would be 70. But I know it's not because the numbers are wrong. But I know it could be, it is 9/10. Because 9/10 of 100 is 90. 9/10 of 90 is 81. And 9/10 of 81 is 72.9. I just know that because, I don't know. I just know it. So our multiplier is going to be 9 over 10. Now, for our equation, we got to find the y-intercept, or when n equals 0. I don't know why I call it y-intercept, because it's not a graph, but you get it. It's kind of similar. So to do that, it's multiplying by 9/10. Now to find it going the other way, we're gonna go multiply 100 by 10 over 9. So basically, you just flip the multiplier. So now I do 100 times 10 divided by 9, which is 111.11111 forever. So it's going to be, our zero term is 111.1, and I'll put the repeated sign over that. That means it repeats forever and ever with ones, because it technically it does. So it's going to be 111.1 repeating times 9 over 10 to the nth power. Now, I'm not going to plug any of these numbers in because it'll take too long. But if you want to get, this is the first term, this is second term, this is third term, and this is fourth term. Alright, last one. Looks like it's adding 1.7 there. I don't know what's doing there, and I don't know what's doing there. So I'm going to do 223.8 plus 23.8 plus 1.7. Which is 25.5. Now I'll add it one more time and see if it works for the fourth term. $27.2, which is our fourth term. So I know it's adding 1.7 every time. So now we gotta subtract. We gotta subtract 1.7. So 22.1 minus 1.7. Which is 20.4. So our equation is going to be t of n. So this is our zero term right there. T of n equals 20.4 plus, not times, because it's arithmetic, it's adding. So it's going to be plus 1.7n. I can write down y equals x equals, so we'll do y equals 20.4 plus 1.7x, if that makes more sense to you in terms of y and x. But they just use t and n for this kind of equations. Now I'll do the recursive. Now that we have our equations, it's easy. Recursive's a little weird, so it's saying t of n plus 1, which means t of the next term. Next term is going to equal the previous term, t of n, minus, or 1 plus 1.5 n. So it might be a little confusing to you, but all it's saying is the next term in the sequence, it's this part, is saying the next term in that sequence is going to equal the previous part plus 1.5. Because it's adding, remember it's adding 1.5 n every term. And then you gotta set t of whatever your favorite term number is. I'll do t of 0. You gotta tell them what it equals. So t of 0 equals negative 1.5. So they know where the sequence starts. Because if they didn't tell them that, you could do t of 100 equals, I don't know, 4 or something. They might think that or something. I don't know. They could think whatever they want. But when you tell them this, they know it. T of 0 starts at negative 1.5. Alright, so next one we're going to do t of next term equals the previous term times 1.2, because that's what it multiplies every time. And we'll write t of 1 equals, I didn't do t of 0 that time, but you can if you want. T of 1 equals negative 1.2. Next one, I'm going to put a lot of numbers here, but do t of next term equals the previous term times 9/10. T of the first term is equal to 100. Alright, and then for the last one, t of n plus 1 equals t of n. So the next term of the sequence equals the previous term plus 1.7. I get that from the equation right here. From the last one, I got it from the equation right here. It's the multiplier. Basically, you put t of the previous term, and then whatever it's multiplying, dividing, adding, or subtracting by. So t of 0 equals 20.4. So they know where to start.